The purpose of lab number 3 is to analyze the movement of a star orbiting a black hole and to gather information about the system. The ultimate goal of the lab is to estimate the mass of the black hole utilizing computer coding. In order to do so, it is vital to consider the gravitational force equation, in which that is equal to negative g, also known as the gravitational force constant, times the mass of both of the objects interacting with one another, times the relative position vector, divided by the distance between the two objects squared. In this scenario, it is known that the mass of the star is 2 times 10 to the power of 30 kilograms. Using this knowledge, it is possible to rearrange the formula in order to solve for the unknown mass of the black hole. Also, in this situation, the concept of reciprocity is important. This means that the gravitational force exerted on the star by the black hole is the negative value of the gravitational force on the black hole exerted by the star. This is vital in this situation because it is important that we analyze the magnitude of the gravitational force in order to calculate the unknown mass of the black hole. As seen in these steps, the mass of the black hole can be calculated by multiplying the magnitude of the gravitational force times the distance between the star and the black hole squared, divided by the gravitational constant times the mass of the star. When analyzing this situation in a computer code, it should first be calculated that Fnet is equal to the change in momentum of the star divided by the change in time. When beginning the computer code, it is important to input the known values, such as the gravitational constant and the mass of the star orbiting the black hole. This situation's time interval is 1 day, and it is important to convert this to seconds in order for the code to be carried out correctly, which is 86,400 seconds. As seen in this code, the initial momentum of the star is calculated by multiplying the initial velocity times the mass of the star. Also, it should be noted that the net force is separated into two components, the parallel and perpendicular forces. The perpendicular component of the force is responsible for the change in direction of the star. Since the star is orbiting the black hole in a circular motion, it is clear that this component of Fnet is not equal to 0. In contrast, the parallel component of the net force is responsible for the change in the magnitude of the momentum, or the velocity. In order to actually calculate the unknown mass of the black hole, it is important to calculate the distance between the star and the black hole. Since the black hole is located at the origin, this distance can be calculated by determining the magnitude of the star's position. As stated earlier, the mass of the black hole is equal to the magnitude of Fnet, which is composed of the parallel and perpendicular forces, times the magnitude of the distance between the two objects squared, divided by the gravitational force constant times the mass of the star. The final step in the computer coding is to assign arrows that represent the perpendicular and parallel forces. Also, it is important to explicitly print the net force as well as the parallel and perpendicular components. As seen in the output, Fnet is equal to 9.248 times 10 to the power of 28 newtons, and the parallel component is equal to 3.35 times 10 to the power of 28 newtons. Finally, the perpendicular component is equal to 8.634 times 10 to the power of 28 newtons. In this output, the force of the black hole on the star can be seen by the arrows representing the forces. Also, the output for the unknown mass of the black hole fluctuates slightly, so in order to estimate accurately, the average of these values should be taken. The result of this calculation is 1.2593 times 10 to the power of 34 kilograms. The parallel and perpendicular forces associated with the net force are equal to the parallel and perpendicular components to the change in momentum. However, the components associated with the net force are due to the attractive force between the star and the black hole. On the other hand, the change in momentum is attributed to the movement of the star orbiting the black hole. If this black hole was replaced with a new black hole in the same location and the movement of the star did not change, it would not be possible to conclude that a difference had occurred.